Hey everyone, so today let's talk about calculus. And I know, but stick with me on this because the real story behind who actually invented it, it's way different and honestly way more interesting than what they probably taught you in high school. So if I asked you right now who invented calculus, I'm willing to bet two names just popped into your head, right? Sir Isaac Newton over in England and Gottfried Leibniz in Germany. For centuries, these two giants have been crowned the undisputed fathers of calculus. And just a super quick refresher so we're all on the same page, what even is calculus? Well, you can think of it as the mathematics of change. It's got two main tools in its toolbox: differentiation, which is all about finding the exact rate of change at a single instant, and integration, which lets you add up infinite tiny pieces to find a whole, like the area under a curve. It's powerful stuff. All right, so let's start with that conventional story. We're going to head back to 17th century Europe. It was a time of massive change. A full-blown scientific revolution was underway. And here are our two main players. On one side, you've got Isaac Newton, the legendary physicist who called his system the method of fluxions. On the other, Gottfried Leibniz, a brilliant philosopher who gave us the elegant dy dx notation that math students still use today. Now, the crazy part is they both came up with it around the same time, completely independently. And this sparked a huge, bitter rivalry over who got there first. For about 300 years, that was the story. But what if that whole famous dispute completely missed the point? What if the foundational ideas of calculus were actually discovered long before either Newton or Leibniz were even born? To find out, we have to leave 17th century Europe entirely. We're going to travel back in time, over 200 years earlier to be exact, to the southern coast of India. Here, between the 14th and 16th centuries, an incredible group of astronomer-mathematicians, known as the Kerala School, were doing some absolutely groundbreaking work. Founded by a genius named Madhava of Sangamagrama, their goal wasn't just abstract math. They were trying to solve very real, very complex problems about the movement of the planets and stars. And this timeline really puts it all into perspective, doesn't it? The Kerala School is making these huge discoveries, and then there's this massive gap, a full 250 years before Newton and Leibniz even enter the picture. That's not just a little earlier, that's an incredible head start. Now, let's get into the proof, because we're not talking about vague ideas here. The discoveries made by the Kerala School were concrete, hardcore mathematical achievements, all written down and detailed in texts like the Tantrasamgraha and the Yuktibhāṣā. So what exactly did they figure out? Well, they discovered the infinite series for trigonometric functions like sine, cosine, and arctangent. Now, if that just sounds like a bunch of math jargon, all you need to know is that these are the absolute building blocks of modern calculus. They're what allow you to make incredibly precise calculations about things that move in arcs or circles, like planets. And if you want to see just how powerful their methods were, just look at what they did with pi. Using one of these infinite series, the school's founder, Madhava, calculated the value of pi to an accuracy that was just completely unheard of anywhere else in the world at that time. This is the number, pi, accurate to 9 decimal places. And just let that sink in. This was achieved back in the 15th century. With no computers, no calculators, this was pure mathematical insight. It's honestly kind of mind-blowing. And what's really wild is that this isn't some brand new revelation. Way back in 1835, an English civil servant named Charles Wyche actually presented these findings to the West. He said, and I'm quoting here, that these mathematicians had laid the foundation for a complete system of flexions. And what happened? Nothing. Crickets. His work was basically ignored by historians for over a century. So this all leads to a huge, crucial question. If this groundbreaking work happened centuries before Newton and Leibniz, and it was even presented to the Western world in the 1830s, why isn't this common knowledge? I mean, that's the real mystery here, isn't it? How could the history of such a massive discovery, something so fundamental to science, remain incomplete for so long? How did it get lost, or maybe ignored? Well, one explanation that some historians offer is a concept called Eurocentrism. It's basically this long-standing historical bias that tends to focus on European achievements, while sometimes minimizing or completely overlooking major contributions from other parts of the world. And this leads us to a really fascinating debate. You see, on one hand, Kerala was a major hub for global trade. Jesuit missionaries were there, and they were known for studying local knowledge. So it's totally plausible these ideas traveled west. But on the other hand, there's no smoking gun. There's no direct paper trail, no translated manuscript that proves this knowledge landed in the right hands in Europe. So for now, it remains a huge, active question for historians. But you know what? The story doesn't even stop with the Kerala school. This is actually part of an even bigger, much older picture. See, the Kerala school didn't just pop up out of nowhere. They were standing on the shoulders of giants themselves, building on centuries of incredible mathematical and astronomical knowledge that had been developed all across the Indian subcontinent. In fact, some historians like C.K. Raju argue that the true origins of Indian calculus go back even further, all the way to the 5th century, to the work of a brilliant astronomer-mathematician named Aryabhata, who was working with these core infinitesimal concepts almost 1,000 years before the Kerala school. 1,000 years. So, what this all really tells us is that the story of calculus isn't just about Newton versus Leibniz. It's a powerful reminder that scientific progress isn't some neat, straight line that goes from one European capital to the next. It's a complex, interconnected, and truly global human story. And it kind of leaves you with a fascinating question, doesn't it? If a story as fundamental as the origin of calculus can be rewritten, what other incredible hidden histories are out there just waiting for us to look beyond the familiar narrative? Anyway, that's all for this one. I hope you found that as interesting as I did. If you enjoyed this explainer, do me a favor and hit that like button, and definitely subscribe for more deep dives into the stories you thought you knew. Thanks so much for watching.